Hello and welcome to our video on calculating Pearson's R using the formula. Now in reality you'll always have your calculator in your exam, so you'll be able to use that to calculate Pearson's R, but it is worthwhile and you could be examined on this formula, so you need to make sure you jot the formula down into your summary book, and you'd need to have an understanding of the different parts of the formula. You remember from the previous video that Pearson's correlation coefficient, or Pearson's R, because it's represented by a lowercase r, is a measure of how close the data is to a perfect straight line. If it's on a perfect straight line, then R equals 1 if it's a positive line, or -1 if it's a negative line. And if it's completely random, it's nowhere near a straight line, Pearson's R equals 0. But most of the ones we're going to be looking at will be somewhere in between -1 and +1. The formula here looks fairly big and intimidating, but we're going to break it down and it won't be too difficult to understand. R equals, and this is sigma again, it's a capital S Greek letter, and it means sum of. And when we actually use the formula in an example, you'll see how that actually works and what that means. So the sum of, so I better put that down here, sigma equals, I'll just put sigma so we know how to say it, and it means sum of. X and Y here are just the two variables that you're using, the two numbers, the X value and the Y value, like they usually are. X bar, you should remember from earlier videos, means the mean of the X values, and Y bar means the mean of the Y values. Mean of X or Y values. So this is the sum of each X value take away the mean times each Y value take away the mean, and then you plus them all together for that top numerator. The n in the denominator is the number of values, and Sx is the standard deviation of x, and Sy is the standard deviation of y. So it's worthwhile just jotting down the meanings of each of these letters as well. Here's an example of how you might use the formula. So the question says, use the formula to calculate the correlation coefficient for the following data. And you've only got a few data points, which is lucky because you wouldn't want to do this with like 100 data points. It would take forever. And they've already, in the example, given you the X bar, the Y bar, so the mean of the X values, the mean of the Y values, standard deviation of the X values, and standard deviation of the Y values. If you weren't given all this information, you could easily put this information into your calculator and calculate the means and the standard deviations, but we're given them, so we're going to use the ones that we've been given. It does tell you to give your answer correct to 2 decimal places, which will be important near the end. So the first thing that we need to work out from this formula is the numerator, the top half of it, this sum of. So I've copied the numerator down here, the sum of each X value minus X bar times a Y value minus Y bar. And this is what that means. So I'm going to start with the first X value. So we start with X, the first X value is 1. 1, take away X bar, which is 4, times 2, take away 5. And you do all of that, and then you add it up. So I've So you need to do that for each of these sets of values. I've put this little table set out for you, and I've done the first row. This is a useful table just to help you organize your thinking. So we'll start with the x value, which is 1, x minus x bar, so 1 minus 4 is negative 3. The y value is 2, y minus y bar, so 2 minus 5 is negative 3. And then this last column is multiplying this column by this column, because that's what this tells you to do. Multiply them both together, so we get negative 3 times negative 3, 9 in this situation. You might like to pause the video now and have a go at filling in at least one more of these sets of values. You should eventually, 1, 2, 3, 4, 5, you should have 5 lines down here. But I wouldn't blame you if you only wanted to have a go at 1 or 2, just to make sure you understand how the formula works. Pause the video now. And here is a completed table. This was the first row that we'd already filled in, and hopefully you've had a go at 1 or 2 more of the rows to fill in as well. Once you get to the end, what we need to do, this sigma means sum of all of these two multiplied together. So these are all the numbers multiplied together, and we just need to add all these together, and we get 23 at the bottom there. And that's the number that we're going to use in our numerator. Interesting to see that these, if you add all of the x take away x bar and y take away y bar, you should get to 0. That's a bit of a check for you. That's because we're taking away the mean from each of the variables, and eventually they should it should even out perfectly, so you get 0 at the end. So bit of a check. If you don't end up with 0 on those two, then you have probably made a bit of an error. On this next slide, I've just summarized that this equals 23 in this example. Okay, next step is to put it all together into the formula. So I've rewritten the formula out here, and we know that the numerator equals 23. So in the next line I've put 23 in the numerator. We know there are 5 different data points, so we can put n equals 5, 5 take away 1, and the standard deviation of x was given in the question as 2.236, and the standard deviation of y is 3.082. So we put all of this carefully into the calculator, and you will end up with r equals 0.834. Right at the start, we were asked to put our correlation coefficient correct to 2 decimal places, so we can round that to 0.83. So it's a positive correlation, and it's pretty high, pretty close to 1. So the data is getting closer to a straight line. Thanks for watching the video.